Welcome back. In this video, we're going to simply dive into it and get a triangle on the screen. In Vulkan, getting a triangle on the screen is notoriously difficult, but in Metal, it's nice. It's easy, it's nice. So the first decision we have is what type of app we want to create when we open Xcode. For this one, I'm going to go iOS. Simply for the reason that I can plug in my devices and view it, which I think is super cool. So I'm going to fire this up. We're going to call this Hello Triangle. Sorry, let me go back through that. So we're going to call that Hello Triangle. Use our own name. It doxes us. That's perfectly fine. I'm going to be doing this in SwiftUI. In Swift, I mean, it's the way of the future. So we're going to create that. And don't worry, that's fine. All right, a little bit overwhelming maybe the first time we see it, but we'll get used to it. So we have our app here. This is kind of the entry point for our app. So we have the Hello Triangle app, which is an app. And first thing we do is we return a content view. Now, content view is this structure here. And at the moment, we've just got some text saying, hello world. So what we want to do is we want to create kind of a renderer object and use that renderer object to make a view and insert that here in this iPhone thing, a little metal view. So the way we do that is we need a few things. We need, I'll just import this for now. Metal kit, okay. So we have this content view, and instead of it just being a general view, I'm going to use a UI kit view. So I'll go, and this is a protocol which requires a few things. Okay, so we're going to need a coordinator, and what a coordinator does for us is it renders stuff, but it can do other things as well. So a coordinator is basically a control structure which runs like a render and an update and everything. So I'm going to go ahead and create that. We'll make a new file, a Swift file, and this will be called renderer.swift. Okay, so we have that there, and that is our coordinator that we're going to go with. So what we'll do is we'll create this renderer, and the renderer will take an instance of a view because it needs a view that it is going to render to. Okay, so yeah, no, I'll fix this up in a second. What we'll do is we need a function to create a UI kind of conformant view, and then we need a function to update the UI view. Okay, so let's get into the make UI view. Okay, so what we've got here is we are kind of creating our metal kit view. Create that here. Then we set its delegate. Now remember, a delegate is a kind of agent which is responsible for rendering in this case, and that's going to be our context coordinator, which we created here, which is really the renderer class which we're yet to kind of jump in and flesh out. But where were we? Okay, so we configure this, we set a number of properties, and we also set the device for the metal kit view. A metal device, you may be familiar, metal device pretty much represents the GPU. Okay, so let's jump into the renderer and get this up and going. So we have a renderer, and that needs to conform to a number of things. Metal kit view delegate protocol. Okay, now I can probably get rid of this import foundation. Now this metal kit view delegate relies on, so just these top two. Okay, so it complains that we have no initializers. Indeed, we don't have any initializers. Okay, so now I have a stub of an initializer. By the way, what this does is this underscore, when we call functions, sometimes it requires an argument and sometimes it sticks in the name of the argument when we name that. So for instance, if I go back to my app and I go create this in a frame, but see, the names of the arguments come in the brackets. Now what this underscore does is it protects it so that the name of the argument doesn't have to come in here. So here we called renderer with self, but we don't want like parent self because it could be a private variable and it's not so useful to know the name of it for whatever reason. Okay, so we also need to inherit next step object. Okay, that is good. And then we go back to content view. I accidentally, it should be view representable context. And I've done the same thing down here. It's not view controller, it's view representable context. We can also get rid of this body, and that pretty much fixes it. Of course, our preview isn't going to be very interesting. The preview isn't going to work because the draw code is now looking here inside the renderer, inside the delegate, and we need to actually set this up. So first of all, there's a number of things. And a metal command queue. And as I go through this, I'll be kind of explaining what these things do. Okay, so we go through the same thing of creating the default system device. Okay, so in other words, just querying our main GPU, and we set that as the renderer's device. Then we create a command queue. A command queue is kind of an in to the graphics unit. So any drawing commands are encoded and passed along and committed on the command queue. So different devices have different kind of command queues. That's fine. We set that up there. Then we go ahead and initialize our superclasses. Okay, so now let's get to the drawing code. Okay, So we have set this up. What we do is we create a command buffer or allocate a command buffer from our command queue. A command buffer is basically where a bunch of commands will be stored. We encode those in a render encoder one by one, and then that render encoder is used on the command buffer. Okay, so then we have a render pass. A render pass basically describes the resources which are going to be used. In this case, the color attachment, which is the color buffer. So we're clearing this at like a kind of teal color, red, green, blue, alpha. And at the moment, we aren't doing anything. We're just clearing the screen. So if we just go back to content view and then resume the preview, we have got that teal color working there and all the errors have gone. Okay, just some other notes. So these question marks, because the render pass descriptor, it's basically an optional object, which means it could either exist or it could have a little nil value indicating that it hasn't been properly created. So what this question mark does is it just queries whether that object actually exists before working with it. And that is also what is happening up the top here. When we have metal device, this exclamation point is unwrapping an optional thing. So the metal device is created here. Because this create system default device returns an optional object, so it could exist or it could be nil. We use this guard statement, which checks if it's been created. If it hasn't been created, then it's nil and this guard statement fails. But if it has been created, then it's passed along to this metal device. What we've got is an optional being passed to an to a non-optional. And so this exclamation point is just unrolling that. And it seems a bit esoteric, but if you're coming in completely fresh to Xcode and all of this and Swift, then with practice, you'll get used to this. And the linter will kind of warn you when you're not using things properly anyway. Okay, so so far so good. We've got the screen cleared, but we probably want to actually create things. So let's go ahead and create a new file. And this is going to be a header file. I'm going to call this definitions. So what we've got is we're going to create a shader, and the shader will use data types, and we're going to be sending those data types through the CPU. So we want to have a definition of common data type for both of them, which is why we create a header, and this is what's called a bridging header. So if we go, actually, let me just create this now. So what we want to do is we want to create a vertex description. And in order to create a vertex description, we will need vector stuff. So we'll go include SIMD. SIMD stands for single instruction multiple data, but in our case, it's basically we're using it for vector types. So create this struct, and the struct has right, so we want to set this up as our bridging header. So what we'll do is we'll go to our app, we'll go to build settings, and we'll search for Objective-C bridging header, and this is hello triangle definitions.h. Let's go ahead and go to our renderer, and what do we have here? We've got device, we've got a command queue. We're going to need a few more things. First of all, let's go vertex buffer. Okay, so let's create that in the initializer. Okay, cool. So we just click through the autocomplete suggestions, the auto fixes, and here we have it. So we are taking this list of vertices and we are converting that into a metal buffer. Cool. What we're doing here with the length is we take the number of elements, so that's 3, times basically the stride of each of these things. So memory layout template thing that we're using here works pretty much the same way as C's size of operator. We're going to be using that a lot. Okay, so there we have it. We've gone and created our vertex buffer. Now I need to create our shaders. So we'll go File, New File, and it's a metal file. I'm going to call this shaders.metal. Okay, so we have a vertex. Oh, yeah, that makes sense. We have a vertex function and a fragment function. This is very similar to OpenGL, so I won't be going through this in heaps of detail, but basically the vertex function takes in an array of vertices, basically the buffer. And for this example, we're just really going to be hard coding that based on the drawing index, more or less. And it takes this information and it passes information to the fragment shader. So what we've got is we need a kind of common data type to pass between them. And we're going to use this fragment struct that we've declared up above. So the fragment structure has this position, and this position is decorated with this extra sort of attribute, this modifier here, called position. And what that means is that when we set this position to a value, that sets the position simultaneously on the screen for that fragment. And similarly, we have some decorations here. This buffer 0 is indicating this is, buffer index 0 on the vertex shader. And this vertex ID is indicating that this VID is automatically populated with whatever index the shader draw function is on. So what we'll do is we'll get we'll use that vertex ID to index in and get the current fragment. Okay, great. And we also need to return this so that it can come into the fragment shader. Now the fragment shader takes some input, which is, we're going to go, this is the input stage. In other words, it links it up with the output of the fragment shader. And really, the only thing we need to do is return the color on the screen. So we return input color. Okay, awesome. So that is it. So now we just need to jump into our renderer and load in this shader code. So in order to do this, we're going to need a pipeline state, because we're going to need to create a pipeline and attach it to the shader. Okay, and as we can see here, we need to initialize this. Okay, so we will create our pipeline state here. First of all, we need to open up the shader file, and for that, we'll use a pipeline descriptor. So what we do is we have this library, which is make default library. What that does is it kind of searches the bundle for the app and it says, do you have a shaders.metal? Yes, you do. Okay, so we'll use that one. And then we look inside there and we look for the function called vertex shader. There's a function called fragment shader, and we kind of bind those in to the pipeline descriptor. Then we use the pipeline descriptor to create the pipeline. Okay, there we go. So we set up the pipeline descriptor and then we attempt to create a pipeline state from it. Cool, so we have that, and finally we're going to go down to the draw function and we're going to create all of this drawing stuff. So we have the render encoder. Okay, so that should be set up. So again, we bind the current pipeline, that's a shader and everything, and then we bind the vertex buffer, and then we just draw. So this should be very similar to OpenGL. Okay, so we just go back to content view, resume update. Okay, so it turns out we also need to set a pixel format for our color attachment in order to use our pipeline. Okay, good. Let's try this now. Cool, there we have it. I mean, it works. It's a triangle. And if we run this, then we've got a triangle of some sort. Now it's kind of cut off at the side. That's okay. Hello, hi. It's Get Into Game Dev bonus round to this video. So we have our app ready to go. What we can do is we can hook in a device like an iPad, and up here we have build targets. This is a little shaky, I'm holding it with my hand. So we go. Okay, so we have this hooked in. Now it turns out we need to get rid of all other devices, any other USB-C things, because it might cause it to freak out a little bit. But then we go here and we go to build and we go to iPad. Sorry, that just sets the target. Then we hit run. Build succeeded. Awesome. And it says unlock iPad to continue. Okay. So we unlock that. And we got that ready to go. It says could not launch Hello Triangle because we need to verify it. So we go here, it says unable to verify app. No worries, we'll just go to settings, general, and this is general VPN and device management. Up here, Apple developer. Go ahead and trust it. Should always trust Apple. I think they're a trustworthy company. All right. Let's hook it up to internet. Let's hook it up to, yep, good. And then we go down probably dox myself 10 times here, but that's okay. Okay, verify app. Yes, verify it. So that didn't take much work. Okay, so we can just go. There we go. And there we have it. It's a beautiful triangle. Just like on the catalog. Just like on the preview. I don't know, but I'm really amused by the fact that I can run code here and put it on my device. Anyway, so that's it for now. Hope you had fun. And yeah, I'll see you in the next one. Bye.